All right, everybody. Thanks for being here today. We're going to cover a lot of material. We're going to go really fast. If you have questions, put it in the chat. At the top of your screen, you'll see a little green slot-looking shape. It says SolidWorks Expert Tools webinar. That'll be the one that we're coming up on the 12th. That'll be a Transformers-themed event. Thank you, George. Thank you, Jeff.
It's a cool one.
It'll be a cool one. We're focused on that. But Darcy, we got to hurry because time is money, and you know I love that money.
I love that money.
All right, let's go.
The main presentation is about to begin.
I just got three things to say. God bless our troops. God bless America. And gentlemen, start your engine!
I'm Steve Darcy, Elite Applications Engineer, expert in 3D design engineering, robotics, automation technology, and robot man. Most interesting man in the world for 3D Experience World. And I also have done a fireman helmet simulation webinar, which is pretty cool if you haven't seen that. Got a little QR code in case you need to reach me.
My name is David Kersley, Senior Application Engineer here in Austin, Texas with Darcy, SolidWorks Elite Certified. I like to think of myself as an astronaut, a professional shark surfer, a part-time Sith Lord, and a race car driver. If you need to reach me, there's a QR code on the bottom right.
All right, so here's the race rules. David and I, we're going to find out who's the fastest. The results are based on the live event from 3D Experience World. So we had some little kazoos. Whoever liked the videos best, David versus Darcy, made some noise. When they made the noise, we recorded the noise, decibel reader, and then that was pretty much the votes for the winner. So here's the little setup. We have, of course, SolidWorks. We're using Motion, and you do have to have SolidWorks Premium for the motion analysis part of this. And what we did is we just ran two cars, and depending on what the results were set to, will depend on whether the path motor is actually going to make the car go faster or slower. All right, so in the agenda, we have different heats, 6 different heats. And each heat, I'll do a demo, Dave will do a demo, or vice versa. And then, of course, whoever voted for the most will decide who wins. So on to heat 1. So I'm going to start off with speed matters, and then David's going to go with speed matters with the fill pattern. So, of course, you got to start off with SolidWorks demo with a simple block. And I'm going to go into the sketch. And in the sketch, we're just going to do a pattern here. So we'll select on the entities. We'll do a 19 by 5. Give it some dimensions and hit OK. So simple linear pattern in a sketch. We're just going to do a cut extrude through all. Hit OK. And we've got our pattern. So how do we find out how fast that actually is? We're going to go to the Evaluate tab, do Performance Evaluation, and we'll look at the total rebuild time. So right now we're here at 0.58. All right. Then we're going to do the exact same thing, just a little bit different way. So we're going to do, I've got the cut as a feature, and then we're going to do this as a linear pattern. And then again, we'll go to Performance Evaluation, and notice the preview time, the rebuild time is 0.06. All right. So our results, sketch linear pattern is 0.58 seconds, feature linear pattern is 0.06. So if you're going to do it, do feature linear pattern. It's much faster. So then I went down a little rabbit hole on whether blind up to surface, up to next, or through all is faster. And I wanted to just find out what's best. So we took a look at the evaluation results, and they all came out 0.06. So for the most part, it doesn't matter which way you do that. Pretty cool. But it's good to know. All right, so then we decided to do something a little bit even like harder. So we're doing a circular pattern in this, and I'm going to do it in two different methods. So initially, I'm just going to do a cut extrude, and the cut is going to go up to surface. There's a little surface back underneath there. And I do two different cuts, and then after the cut, I'm doing a circular pattern. So you can see it actually takes a little bit more time to do it. And if we go to performance evaluation, I did speed that up. It did take about 18 seconds for it to complete. So then we're going to do this a little bit different. Instead of doing a cut extrude, I'm extruding these solid bodies up to surface. So I've got my two solid bodies. And then again, doing a circular pattern, but in this case, doing circular pattern with the bodies. And I hit OK. And that circular pattern goes fast. No resulting geometry to do. So it fills in just fine. All right, then we got to do a combine to cut and remove that material. And there we go. And then evaluate, performance evaluation. And you see this took 13.8 seconds. So when we put them side by side, if I do a circular pattern, it's 18 seconds. If I do it with the solids, then it's 13.8. So it is faster typically. And in older releases, it's way more faster to do a solid pattern and then do a subtract. All right, so fast parts equals fast assemblies. Feature patterns are typically faster than sketch patterns, and pattern bodies can be faster than patterning features. That's fast.
Nice,
right.
Darcy.
There you go.
All right, so what I'm going to show here is what we call a no seed pattern, and this turned into a light. So I wanted to start with the same size plate that Darcy had, and that's going to be sketch number 1. So keep that in the back pocket. So I'm going to do a fill pattern. And when I do a fill pattern, notice over here on the left side, I've got all the properties. And all I've done so far is just select the boundary that I want to put the pattern. And what I'm going to do is I'm going to select my horizontal, my vertical spacing. I'm going to select an edge to start the pattern down. And I'm going to hit this button that's over on the left. It's called Create Seed Cut. Now, when I do this, if you haven't used this before, it's pretty cool. I can pick 3 or 4 different shapes, and I can control it, especially if I have like a pentagon or octagon. I just set it. But let's match up to Darcy here. So 0.625, right? Looks exactly like Darcy's. So I say, OK, execute it, the command, D to confirm, and I go to performance evaluation. I can see that right now, Darcy was what? You were what?
0.06.
0.06, and I'm 0.17. So Darcy's a little faster. But let's take a look and think about what happens not only when we make parts, but we have to edit parts. And that's where this may become a huge advantage for you. So let's take a look. So speed matters, just like a NASCAR pit stop, right? So what if I come in here and I have to change that from a diamond to the hole? Look how quick I changed that. All I did was change the seed cut there in the fill pattern. Now, if I want to change it back, I can, okay? Now, what about instances to skip? So when SolidWorks looked at this plate, it looked at the boundary and it created this pattern. I can turn all those instances on, whether I manually select them or I do a shift select. And if I had to do a hard chamfer here on this plate with a seed cut there, I'd be in agony city. So here, I'm just going to do a right-click, clear, performance evaluation. And with a circle, notice my time is down to 0.08. So that made it a little bit faster. And again, I'm a little bit faster here just for the ability to change things. So sometimes maybe you want to be a little slower, but go faster on change. Because unfortunately, we do have change. So I got the plate, and this is where I kind of made a mistake, but I'm going to show you the deform tool, and we'll talk about why that was a mistake later. So I've got my second sketch here. So keep that in mind. So that was our second sketch. I'm going to do the deform tool. But to do that, I'm going to create a copied surface. I'm going to offset 0. Okay? I'm going to come back. I'm going to hide the original body. And now I want to deform this surface. Okay? So I'll hit the deform tool. And I'm going to say, okay, use this align segment here and this one here to apply the curvature. I'm going to say uniform. I'm going to go pick my surface, and you can see the yellow preview. So I was quickly able to keep the pattern. The holes look good. Pretty happy here. I'm going to deform it one more time, and this will be the third sketch that we use to create this part. So I deformed it one more time with a third sketch. Pretty good. I'll turn off my sketches. And this part looks pretty good. Now to turn it into a solid body, all I had to do was use the surface thicken tool. So now I quickly went from just a surface into a thickened part. So I got this thing up. Looks good. Okay, so here's where we run into a change. I wanted to change the shape back to the diamond, right? So watch what happens here. I just simply changed it, and oh man, like Cal Naughton Jr. said, or Ricky Bobby, help me, Oprah Winfrey. So I had to make a quick change. So I'm going to pick on the face. When I go back to the original body and pick that face, guess what? It's now updated not only the original body, but the curved body we deformed earlier. So I'm moving pretty fast here. So now what I want to do is one more type of pattern to complete this light. So there's my part, and I'm going to do a move copy body to create the pattern. I'm going to say 7 instances, and when I picked on rotate, something interesting happened. I said 45 degrees, 7 instances. I had to go back and recheck the copy box. When I do, there's my cup. Looks like something out of Game of Thrones, right? But here, all I'm going to do now is do a cut with surface. I'm going to cut half of it away, and there's my light. So when we talk about going fast, we used our fill pattern. The other thing is we didn't spend a lot of time on sketches. There was 3 sketches to create this part. So some of the benefits to you on this are I didn't have to use sketches when I did this fill pattern. And I put a little asterisk there because we're going to show you a way, if you have a custom profile, how to use that later, okay? And I can quickly change the pattern. Now, the mistake I made on mine was I did the offset surface and then deformed it and then thickened it. I could have just deformed the body. That would have been the better way to do it. And I have full instance visibility for adjustments. So those are the benefits for you there. All right. So then at 3D Experience World, we did a Heat 1 vote. And here was the results from that first one vote.
All right. So what we have to do is just edit that pathmate motor. So we'll put the dimensions in, and then we're just going to hit the little calculate button. Let's pan in just a little bit. Let me reset that replace key. There we go. Now we hit calculate, and it looks like blue wins. Woohoo! All right, moving on. All right, let's move on to heat number 2. Darcy and Dave, curve driven, sketch driven, and then Dave's going to do composite curve. So on curve driven, there's a cool offset option on the surface. So I'm just going to use that tool. And you can see it makes that whole curve there on the surface. But I need to position my hole. So I'm just going to go ahead and draw in a line in that 3D sketch, make that construction. Then we'll go right into Hole Wizard. The sneaky part about this is I'm just using a 3D sketch and position that on the surface first and then move it to where the location is. And that way it'll always stay normal to that surface. So then we're going to go into curve driven. We'll just select on the 3D sketch. We can make more or less in there. Looks cool. And then make sure you do the face normal and select on the face. That way all the hole locations are going to be normal to that face. Turn off our 3D sketch. Then we'll go into kind of a section view mode so we can actually see all that the holes are normal. And that looks pretty cool. All right. Another one of my favorites is a sketch-driven pattern. And the reason why I like this is because it's very simple. We just put some points out there in just a 2D sketch. And then we just go right into the pattern. So we'll do sketch-driven pattern. We're going to use that same sketch with those 3 holes. We'll pick on the boss and that hole and hit OK. And there we've got them done. So this part goes out to you woodworking peeps out there. That's a little wood clamp. It's kind of cool. All right. Something else I found out that the sketch-driven pattern doesn't have to be a 2D sketch. So I'm going to start a 3D sketch. And in here, I'm just going to select on 3 points. They can be in different X, Y, and Z locations. And then after I have that sketch with the points, we can just do, again, sketch-driven pattern. And we'll use that 3D sketch. In this case, I'm going to pattern bodies. So the only thing sneaky about that is you usually have to select the point, the reference point that you want to go about. So now you can see all those little plates are in there. Looks good. And then we just got a simple pattern to finish off one side and then, of course, mirror it to the back side. and we're done. So pretty quick, fast ways to create your patterns.
That is neat.
Cool. All right, so what are the benefits? Pattern normal to curved surfaces. You can easily copy from point locations, and you can also utilize a 3D sketch for your point locations on the sketch-driven pattern. Go for it, Dave.
Cool. So I'm going to show you guys this one's called curve-driven pattern. We're going to focus on creating the green piece, and I've got a multi-body part here. And this was a jewelry box that I made for my daughter that she said, Dad, I need a jewelry box. So I thought, oh, this will be easy. But then I ran into problems and thought, ah, crap, let's see how this worked. So I'm going to show you both the errors and how I fixed it. Okay. So I started out, this is that middle body, and I just did a cut. Now, key point here, make sure you do 3 through all. And because it's a multi-body, I just selected the body I had open here. Okay. So you do not want to do up to surface. Up to surface, again, will not work when we try and go around the corner. So I thought, well, I'll just do curve-driven pattern. I'll go pick that feature I just did, the cut, hit the green check, and guess what? It didn't work. It only went around part of the way because it only used that one line segment. All right, so option 1 failed. Let's try option 2, right? So I thought, well, I'll do what Darcy just did. I'll make a 3D sketch. And I came in here, did a sketch, picked those 3 line edges right there, converted them, and I was like, I'm off to the races. This will be great. This will be easy. A neat little trick, if I hold both of those, the cut and the 3D sketch down, when I pick on curve-driven pattern, everything is populated correctly. But look what happened again. We got a serious problem. It didn't follow that path. And I tried clicking on every button over there to try and make it work. And you know, like most of us, we just click on the left buttons, and sometimes it works, sometimes it doesn't. In this case, it didn't. So what would work? So what I did here was I tried a composite curve, okay? So I used a composite curve, and I grabbed those same 3 line segments I did with the 3D sketch, but guess what? The composite curve is going to look at it now as one single line segment. So when I do my curve-driven pattern, I'll go up, I'll grab my composite curve. Notice it went all the way around the corner this time. And I can set the direction arrow right there. Cool, looks good. I'll go grab my cut polygon, and I'll hit the green check. And guess what? It patterned all the way around the corner. So now all I had to do was add another cut. I went over to the feature tree. I reorganized my feature tree. I added an additional cut. I have to add that back to my original pattern. And guess what? There's that body. Now to make this, this is a square part. So all I did was a mirror, and I checked the merge entities. So once I did that, all I had to do was come back in here, add a few fillets. So started out trying one thing, that didn't work. Tried a 3D sketch, that didn't work. And it was the composite curve that allowed me to make that around the corner. So again, some of the features and benefits to you, the end user here, is I can get a pattern to go around a corner, which is really cool, and it's symmetrical. It's great if I'm doing something like a multi-body part modeling, like this little jewelry box, and it made it easy for when I went ahead and 3D printed the part. So pretty good. Hope you guys saw something there. So here's where we did the second round voting. It was Darcy versus Dave, and everybody blew on the kazoos, and Darcy went ahead and updated the race information.
All right, so we'll make our little changes in here. Add this for heat number 2. We'll go ahead and reassign where the orientation is and calculate. So there we go. Dave started winning at the beginning. And we pretty much tied. So I caught back up on heat number 2.
Well, it's going to be a tight race today. I feel the need for speed. All right, in this one, I'm going to show you guys how to vary your pattern using the sketch, okay? And then Darcy's going to get into variable pattern as well. So let's take a look. So this is a part here Darcy gave me. I think a coworker had done it, but let me kind of back you into what did here. I made a solid body with some lofts. I cut it in half. I did an offset surface. I'm going to use that surface to extrude up to. I then did a sketch on the midplane, and I projected it. I did a split line. So now I've got 2 regions. I want to create a cavity from that first region, so I did a surface cut. Okay? So then when I cut it, I went ahead and filleted the corners. So that's all I did to create that cavity. Now here, all I'm doing is I'm doing an offset sketch, and I'm going to offset it 1 millimeter. All right? So real quick, real easy. Here's the key for us. I'm going to go ahead and put this little slot in here. The tangent relationships are what's going to be key to us here. I'm also going to set this dimension here to 8. And I'm going to use this to set the direction. Now I need to fully define this guy, so I'm going to go ahead and put a radius on it. And notice that I've got a fully defined sketch, okay? And what I want is this slot to go, in this case, left to right and follow the orientation of that offset sketch. And in order to do that, I needed that tangent relationship in there. So let's see how that's going to work for you. The first thing I had to do was create a solid feature in order to pattern. So I just did a feature and I said extrude up to surface in that original surface. So again, my grip is maintaining the shape of the original body. So I'm going to do it a linear pattern. I'm going to pick on that 8, and that's going to set the direction. On the left side, under options, check vary sketch. And that's the key here. I'm going to come up, I'm going to set the number of instances, and I'm going to do an up to vertex. I'm going to pick the vertex on the far end of my cavity, and I'm going to say, hey, I want to stay off of that by 3 millimeters. And where am I going to pick this other little vertex? So I'm going to pick this other vertex. It's going to say from here to there, right? And I'm setting everything up. Now, by doing instances like this, I can go up or down, and I can just quickly control the number of grips. Now, this is great because what I can do is I can set these, and overnight, I can print 3 or 4 versions, right? So to finish this off, all I did was a cut through the middle. I filleted the ends of it, and it's all set to go. The nice part about this is if I wanted to make 5 or 6 or 7 configurations, go home, while the printers are running, the next day I can come in and have folks test out this grip to see which one's the right fit. So hope that helps you. The advantages and the benefits to you guys here is this. I can update the patterns without editing multiple features, and that's where we're going fast. Again, the more features that you have to edit, the more likely you are to make mistakes. And you're also likely to end up with a bunch of ketchup and mustard in your feature tree. And we don't want that. So this keeps your patterns up to date, reducing those rebuild errors.
Cool. All right. So I'm going to show you something that's kind of cool that I didn't know. But notice that when you do just a linear pattern, you can actually use lines, axis, dimensions, and circular faces to set the orientation. So this is just a quick little tip. So I'm doing just a linear pattern, but I can select the cylindrical face, and it's using kind of the axis of the cylindrical face for the direction. So I just put 5 of those in there real quick, just for the heck of it. All right, now let's get into the vary pattern. So I've got 2 features that are sitting in there right now. The variable pattern, kind of the way it works is it just uses a table. So I've got my table. I'm going to just add a new row, and we can just put in what the X and the Y locations are. So I'm going to make one go up 15 millimeters, or I'm sorry, negative 15, and then up 17 millimeters. So I've got 3 of them in there now. But the cool thing is, for all you Excel spreadsheet lovers out there, we can actually import an Excel spreadsheet. So if you can do all your equations and stuff in Excel and then import the table. So I actually did that, 3D printed it. It didn't feel very comfortable. So I went back to Excel. We made one that had a straight pattern grip. So give that a second to load in. We'll update that preview. And notice I'm not only varying the location and the height and the width, but also the sketch dimensions. So a lot more versatile and fast. All right, so that looks pretty cool. And that's a variable pattern. So the benefits are, of course, it utilizes Excel spreadsheets. It dynamically controls all pattern instances, all in just one tool. All right, so now for heat 3 vote. So we got our results. We need to make our changes. So I go down to heat 3. We'll put in 73 inches for that one. And 66. And then we'll hit the calculate button. We'll go through each of the different heats. So Dave's went in. We tied on heat 2. And Dave pulls off. He actually won a little bit in heat 3. Looking good.
And now, a public service announcement. We would like to talk to you about a subject that affects 2 out of every 1 engineers. Have you ever had to make a pattern and said, nope, not today, Satan, or just unplugged the laptop? It's called trypophobia. the fear of patterns.
What do I do?
Never fear. There is a cure, and it's called Patternol.
Dave, that's amazing. Are there any side effects?
There are joy, happiness. Your feature tree will be free of ketchup and mustard. Puppies will like you. I guess in some adverse cases, stomach pain and explosive diarrhea. But don't worry, you'll be okay.
Sweet. I'm going to eat a mini right now.
Cool. This will have you seeing patterns in no time. Trypophobia and Patternol. All right, heat number 4. We're going to talk about smart components and pattern-driven component patterns. All right, how many of you are using smart fasteners? You can just chime in on the chat, but the advantage to using smart components is the ability for us to be consistent as not only individuals, but as a team. So how do we do it? I'm in an assembly, I'm going to say smart fasteners. And what I'm going to quickly do is I'm going to just hit add once I pick this face. And you'll notice that when I do that, I can add top stack or I can add bottom stack components. And the bottom stack being on the back side. So if I pick bottom stack, I can come over here and pick a washer. And notice as I pick these items, they appear right on the back. And the good news is when I go to do a bill of material, all these will be accurate, right? So now I've got my washer and I put that on the front. We say, okay. So that's kind of first step. I've added my hardware. All right, so what's the next step? The next step is I'm going to make a smart component at the assembly level. My smart component is this connector. The components are going to be all the screws, nuts, bolts, washers, whatever that I want to go with it. So notice that they turn like a magenta color. Cool. And they're automatically populated. Now the features, I want this advanced hole that I've got here and this hole pattern. Now in this case, it did make me select the other hole patterns, which was weird, but I would have thought it would have grabbed all of them. But over at your component level, now when I go to the connector, look what I've got over here on the left side. All those components are with it. The advanced hole, the screws, nuts, bolts, everything. So back here at the assembly level, let's implement this change. Okay? So here's my smart components, and I'm going to insert it. Now you can do this a myriad of ways. I just did a control left mouse drag and I hit the green check. Now you'll notice that I've got a little lightning bolt here. If I pick on the lightning bolt, SolidWorks says, hey Dave, what's the initial face? What's the ending face for my cuts, right? Because I've got those advanced hole cuts that I want to bring over and the hole pattern. So when I hit the green check and I rotate this around, guess what? There's all the hardware. I can see that the hole came. But what about my hole pattern? So if I come in here and I hit Shift Tab or Tab, I can hide a body. So I can see that the hole pattern came through. And if I hold Shift Tab and hover it over where I think a body would be, guess what? It reappears. So the advantage here is I was able to add a connector and, 16 pieces of hardware in just a few seconds. And what I can be super consistent, and so can the rest of our engineering team. So I hope you find that useful. The benefits here again, faster assembly creation. You saw how quick it was. My BOM is going to be up to date. I've got reduced errors and reworks, and can make this with configurable designs.
All right, so I'm going to do pattern-driven component patterns. I like the smart components, so I'm going to kind of go the same way that Dave did. I'm going to do a coincident mate real quick, just plop that guy inside there, and then hit the little lightning bolt to insert the smart feature. And in this case, it's creating the hole for that bolt. So all I have to do is select on that top face, hit OK, and now I've got my pattern. Cool thing is, if you drag this guy around and just hit the update button, then it's got to create that hole in that new location. So just to put it in the right location, let's put a concentric mate on there. There we go. And it's up to date. But now I want the hole in all the different ears. So let's open up the part in its own window. You can see the smart feature is in the feature tree. So I'm going to drag it up above the circular pattern. We'll edit the pattern and just add that hole to the pattern for the ears. So now it's in all 4 of them. That's great. Let's save that. But now I don't have the bolt only in the first one. So we're going to do a pattern-driven component pattern, which means that the assembly is going to link to the part. So I just need to select on that ear, and if there's 4 ears, then there's 4 parts. And so the cool thing is I can change it. So I'll just double click on that dimension. We'll see what 5 looks like and rebuild. So I got 5 ears. We'll do 6, That's cool. I'm going to bring it back down to 4. We just want to make sure that everything updates right. And there we go. Save it and close it. So the benefits here, the assembly is driven by the part pattern. It's faster updates and rebuilds, utilizes smart features, and the BOM bill of material is always up to date. All right, so heat 4 vote. Let's go. So we have to add in the 4th heat there. Let's go change some of these dimensions. And we'll just recalculate. And here we go. Round heat 1. 2, we tied. 3, Dave started taking the lead.
Oh, yeah.
And 4, oh, I'm coming around.
Oh, man.
Coming around the end.
Who's doing the voting in this thing?
Who in the
I
world?
disagree. I disagree.
All right, moving on to heat number 5. Go for it.
All right, so we're going to go back to that fill pattern. We're going to use a custom feature, and then Darcy's going to show you some awesome stuff with 3D textures. So we're going to make this grip right here, okay? We want to make a prototype of it, but what we're going to do is we're going to focus on that green area. So I've already got that pocket, and I've got this surface here. Now I've offset that pocket surface by 0, copied the surface, basically. So what I need to do is a couple things. I've made my part symmetrical, and I'm going to have to flatten it. So the first thing I'm going to do is I'm going to use an intersection split line. So I'm going to grab the plane that's going through the middle of the surface, and notice that yellow line? That's going to be my line here that I'm going to flatten from. I needed a point of reference to flatten from, so I created that with that line. So when I go to surface flatten, which is in SolidWorks Premium only, notice anywhere that I picked on that original yellow line, it's now pink line in this image here, wherever I pick, SolidWorks flattens the surface from. So I can come back in here and hide that original surface now, okay? So let's do that. Let's come in here. We'll use Shift Tab and hide that surface. I'm going to come in and I'm going to thicken the body, and I'm going to thicken it the same as my cavity depth, the 0.5, and I'll hit the green check and make sure merge result is unchecked. Now I'm going to advance this just a little bit. All I did was make a sketch with a cut in it. Now I've got a custom feature. I'm going to use fill pattern, and I'm going to set the options over here on the left side. Okay? And just like we did before, we set all our options. And over here on this time, what's going to be different is what I want to pattern is this original cut. But I need this directional arrow here, or the direction for the pattern. Okay? So I'm going to zoom in. I'm going to pick on that cut that I just made. Okay? Great. And now I can see that it's going to pattern. I'll pick the surface, and the cool part is, notice over here on the left side, it gives me an instance or a validate count. It tells me there's 103 instances of this in here. So now I can go back and adjust the spacing and get a different count for different grip prototype testing. So when I hit the green check, now all I have to do is the hard part. And this is something I screw up every single time. I'll go to convert entities with a new sketch, and I'll say inner loops 1 by 1, and I'll pick the face. Where I fail to do is I always fail to hit that inner loop. If you don't, it just gives you the outer profile. But if you select it, guess what? It grabbed all those inner profiles. So I'm going to turn that sketch off for a second, or that surface off, that body off rather. Turn it off, and now I got to get that sketch onto the grip. So how are we going to do that? And we're going to use a tool called the wrap feature. So what I want to do is I'm going to come down here. I'm going to hit wrap. I'm going to come up here. I'm going to grab my sketch, and then I'm going to grab the body or the surface that I want to go up to. Bonk. There it is, and I got a preview. And I'll set whether I want it embossed or debossed. And down on the left side, I can set the accuracy of this. Just for speed of today, I'll go ahead and hit a low accuracy, and all I have to do is hit the green check and see how quickly I was able to get that on there. The nice part is if I needed to create a bunch of prototypes of this, I could play around with the settings, print them overnight, come back the next day, and decide which one of those grips is best. So the benefits of using this is I can use custom feature profiles on that fill pattern, and it's great for prototyping and 3D printing. Again, I can just create a whole bunch of different versions, print them overnight, and test out the next day. And I did all that by utilizing the wrap feature. What you got, Darcy?
I got something cool.
All right.
I'm going to do some 3D texture. So I'm going to use my little handle grip here. And right now it's flat, so we're going to kind of go through this step by step. And the first thing we need to do, I'm going to put a knurl pattern on here. And in SolidWorks, if you go underneath here, we have some 3D textures that are automatically included. And when I drag that on, make sure you apply it just to the face. And then it's always going to be a little bit weird, so you have to go in there and edit the appearance. And on the mapping, I'm going to kind of straighten that up. First, I'm going to tell it to map on the surface and not projection. And then we can scale it up and down. And the main thing here is the difference between the white and the dark. So when you're choosing a texture, make sure that you have something that has very high lights and very low darks. All right, then we just right click on the solid, go to 3D texture, check the box for that. And then you can see the distance. We can make this really tall if we want. We can also change white up and black down, or vice versa. And then we can also change the element size. So in this case, depending on what type of 3D printer you're printing on, will depend on what your texture needs to be. So that looks pretty cool and pretty easy to create. We'll go ahead and make it I like it that cyan color. So we'll save that. Change it to where we just see the faces on that, and that looks great. So pretty easy to create a pattern. You can pretty much make a pattern on anything with a JPEG, a black and white JPEG. So here's some other things that I did instead of just the diamond pattern. You can also do dimples. You can also remove the dimples just by hitting that reverse option and hitting the OK checkbox. So what are the benefits? It's great for 3D printing, reduces the amount of features, and quickly utilizes complex patterns. All right, heat number 5. Let's vote. So let's see what the results came out for heat number 5.
Cool. Round the corner.
Round the corner.
Down the back stretch.
And then I was catching you on 4
Oh,
and 5.
looks like you're going to get a victory, Darcy.
That's right. And you know what, Dave? Can I win all the time? It'd be great if I could win and be number 1.
Number 1? You can't be number 1, Darcy, because if you're number 1 and I'm number 1, that makes 11.
Oh, yeah. Okay. Well, you can win then. All right. So heat number 6, we're going to do lattice and visual scripting. That's some pretty cool stuff. So let's get to it. So here we go. Why lattice matters. It enables fast, lightweight, strong structures. It has a really good workflow with SolidWorks to CATIA to 3D Experience. And it's ideal for additive manufacturing. So how do we do it? We, of course, get into SolidWorks. There's a couple different ways we could do it. I'm just going to do this with a surface and extrude that. And then I want it on the other side as well. I want to do 2 different patterns. So I'm just going to mirror it. And that's it. Then we take our SolidWorks part and we're going to save it up to the 3D Experience platform. I like to put it into my lattice bookmarks so that way I can find it easy. And then once it's on the cloud, then we just select on the Lattice Design role, and that's going to automatically start up CATIA in the Lattice Design role. And then I can just drag and drop and open that thing up in Lattice Designer. All right, we'll maximize CATIA. And then this is actually a SolidWorks part, so I can't make changes unless I do what's called an abstraction shape. So in the abstraction shape, I can make extra little additions to the feature tree here. So we're going to copy that in there. We're going to close up these surfaces. So it's just a real simple way to kind of make these things booleans. That's where the lattice is actually going to happen in here. And then 5 quick, easy steps for Lattice Designer. What part body are we going to do it to? What are the different cavities? So here I'm just going to select on these volume cavities. So one there on the right, and then we'll make another one on the left. So it's looking good. And then now that I have those 2 in there, I need to tell it what am I going to do with each of those. So am I going to do it with bars or TPMS? TPMS is surfaces. And then we have different options for the different cells. And this one I'm just going to use cubes. And we'll go ahead and do the one on the left, and we'll do that one as diamonds. We have a lot of different options for the length and the radius, and you can also orient it in different directions as well. We'll say OK to that. Concept information is just some options on how much filling is happening to it. And then step number 5 is just the decimation sag. Hit that and hit OK. So pretty quick and pretty easy. This would be very difficult to actually model up, especially when it hits those side faces. You have to put all those fillets and stuff on there. So this is a really quick, easy way to make lattice designs. Now I went ahead and did an update to it just to make a really cool shape. And it's pretty fast. This took, I think, about 1.5 minutes to actually create that lattice structure.
How long would that take you in regular SolidWorks? It'd take you a really long time to make these models.
I would have to hire somebody else to do it. Would not want to do it. So some other lattice applications, if we did surfaces, we could do some stuff for heat exchangers. You may actually be buying some sports applications that already have some lattice structures in them. And any medical applications, you're going to start seeing these in more and more stuff as well. All right, so the benefits are, of course, create complex, lightweight bodies, reduce modeling times, 3D print manufacturing, and optimize design for strength to weight ratios. All right.
Cool. Next, we're going to talk about visual scripting. And if you had to make this part in SolidWorks, well, in the words of Ricky Bobby, are you kidding me right now? And for those seeing visual scripting for the first time, here's a little sneak peek. Mike Britton is going to have a webinar coming up. Stay tuned. Check out the GoEngineer calendar. Mike's going to be doing one on visual scripting and lattice, and I think it'll pretty much just, like the rest of us, make our heads go, wow, I can't believe that we can do that now. So keep your eyes open for that. But this is what visual scripting looked like. I've got the model over on the left side, and over on the right, you can see what we have on this gray screen. These are what we call the operators. So let's take a look at it. So last year at 3D Experience World, we created this rocket, okay? Our space exploration rocket. So what we want to do is get this into visual scripting from SolidWorks. So we're going to pick and we're going to do some surface, right? Either offset surface or copy the surface. And now I'm going to bring this up to the 3D Experience platform. So once I've got it, I'm going to save it into my bookmark so I know a nice, easy way to find my part, right? So it's in 3D Experience. I'm going to go over here to the left side. I'm going to click on the compass, and I'm going to open up the app, Visual Scripting. When I open up Visual Scripting, this is a CATIA-based role. There's my rocket, right? And so now what we want to do is start to get this guy in here. And what we want to do is we want to play around with generating like a really organic heat shield. So let's isolate this surface, and then let's start playing around with visual scripting. So here's my surface. I'm going to go down here at the bottom, and I'm going to pick on visual scripting, say OK. Now over on the left, what we're used to when we do stuff in SolidWorks is a feature tree. Over on the right, what we're doing is visual scripting, and these are called operators. Think of the operators as just a feature in your SolidWorks feature tree. That's how I explain it to myself. Hopefully that helps you out. So now what I want to do is I want to start to divide this thing out. I want to create these subdivisional surface, and I'm going to use these points. Now I have all of these operators, and notice that I'm drawing a line between them. So I'm saying, hey, do this and do the next thing and do the next thing. Just like in SolidWorks where we have features that are referencing each other. So what we're doing is we're doing Voronoi, we're creating boundary surfaces. And I'm starting to, if you watch over here on the left, as I create this script over on the right using the operators, I can start to see that this surface is now being broken into smaller pieces. So what do I want to do now? I want to put some fillets on these corners. So I'll set the corners. Pretty good. And I set the radius. Okay, great. Now the next thing I want to do is add another operator. And I want to go ahead and fill, and I want to add these to get some volume to them, right? So let's go ahead and say, let's do this. Now, if you've ever done this in surfacing, this would be a great addition to SolidWorks to be able to add draft to a surface when we extrude it. But look how quickly, with just a couple operators, we were able to take that flat surface from SolidWorks, and with just a little bit of scripting, we were able to create this heat shields. But we're not going to just leave this alone. We're going to try and take it to the next level. So now what I really want to do is to get something that's less mechanical looking and something very organic looking. So let's start to tinker and let's see what happens here. Here what I'm going to do is I'm going to take one operator and reconnect it back to that pattern, right? So now when I go in and look, with just a couple simple operations, think about how crazy that surface would be to create in SolidWorks. And each one of those, you know, has some crazy patterns, some crazy shapes, and they have draft, and I've got nice spacing, and I can quickly control how that looks. And look at that surface. That's pretty awesome. So that's visual scripting if you haven't seen that before. Again, be on the lookout for Mike's webinar here in a few weeks. Some use cases, folks in the automotive industry are using it. People who use it to design buildings, things like that, they're using it as well. When we talk about visual scripting, the benefits here is I can automate complex geometry. You guys saw how quickly it was to create that. We use SolidWorks CATIA in the 3D experience workflows, and it worked seamless. What you saw there was no punches, no clever editing, just as it was. And I can capture and reuse engineering knowledge over and over again. So pretty nice way to do it. All right, so the final heat. This is coming down to the last lap. So we had everybody vote with their kazoos, and let's see how this race turns out. So here we go.
I think they kind of like the visual scripting a little bit better.
Yeah, it's close. It's so close, and we're gonna have to find out here. I'm gonna need a lot to catch up.
Yep, I was winning at the end. Heat number 5, there we go. Uh-oh, slingshot.
Engage. Shake and bake, Darcy.
Shake and bake.
Woohoo! All right, we want to thank everybody for coming today. We know we showed you a lot of stuff. We're going to go ahead and start. If you want to unmute or put something in chat, we'll go ahead and start answering all the questions. If you need to reach us, there's our QR codes at the bottom. And again, thanks as always for being here.
Thanks, guys. Shake and bake.
Shake and bake.
One of the questions that they asked was, how like performance-wise or stability issues with patterns. And it looks like a couple people were actually have your trichophobia with afraid of patterning. They don't want to do it, but
we'll for the most pattern all, and everything will be good. And
just get some pattern off.
Yep. But patterns. They're just they are finicky. They're almost like a cat. Sometimes you feel like you're clicking the right buttons, and then it fails. You got ketchup and mustard, but. Just a few best practices usually cleans that up, Yeah,
I kind of agree. That's if you do them the right way, then they're just as stable as extrude and revolve and that stuff. But if you do them on some weird kind of ways, then, they can get a little bit finicky for sure.
Yeah. Thanks for all the great comments and questions over in the chat during this event. There's been some great questions over there.
Yeah, looks like we got them all answered.
I like that, Don. Don's going to take some pattern off.
All right.
That's hilarious. So apparently that was a hit. Yeah, I see Jeff Jacobs up there talking about the deform tool. Very interesting. I'm looking forward to watching it back and trying it out. Yeah, the deform tool is very, very powerful. Again, I wish I had done the mistake I made there, Jeff, was I made that by making a surface in another body. What I should have done is just deformed the original body, and that would have taken out that whole error that's in there. But I left it in there because I screwed it up, and maybe my screwing up or learning, as I would like to say, is hopefully helps you and you don't do the same thing. So it's a cool one, and it did a really good job. You notice it didn't really make goofy shapes out of that pattern when we wrapped it around there. Again, allowed us to change the pattern fast. So
yeah,
great.
One of the questions is, when was Deform tool available? I think it's been there for, I'm going to say 8, maybe 9 years. It used to be very finicky, but over the last couple where you actually have, where it's going from and where it's going to, it's been quite stable.
Yeah. I was thinking my gut reaction, Darcy, was 2015 to 2018, somewhere in that window. So we're probably close to that.
I think you're right about that. It is not a premium feature. It should be on every version of SolidWorks.
Yep. I just came from SolidWorks 21 Premium. I've been trying to get up to speed this last week, and half of these new features. Well, all right, Jeff. Well done on the upgrade. If you need any help, just reach out to Darcy or myself. We're happy to schedule some time with you and show you some tips and tricks along the way. That goes for everybody on here. Teach you how to make a wire mesh basket. Yeah, John, reach out to us. We were happy to schedule some time, and it usually these things are trial and error, and you learn. I guess like the Matthew McConaughey green light books. If you learn what you're not, then you'll know what you are. And in SolidWorks, if you know what you can't do, then you'll know what you can do, and then we'll figure it out. So we're happy to help you with that. No problem there at all.
Smart features, can you add a parameter so the screw length can change depending on the thickness of the material? So kind of what I did is I put a smart fastener in for, like, say, for instance, a bolt. So it's actually just creating the cutout for that size bolt. So I can do configurations on the bolt, and depending on what the bolt size is, I can have configurations of all sizes. You can add, I believe you can add multiple smart features. So if you had different tolerances, you may be able to do that. I'd have to do some testing on that, though. Say, for instance, you want something that's a little bit tighter versus looser. You may have to do some changes on that. All right.
Thanks, everybody, for being here. We appreciate you.